Hello everyone, my name is Timothy Lee Grant, and so today I am going to be doing a small little project which is going to be trying to get Python to communicate to an SQLite database. So that's kind of what I want to do. I want to understand how that interaction occurs, how you actually put those SQL statements into the database, how you're able to manipulate things. I just want to understand this concept a little bit more. And the reason is because at work, this is one of the things that I'm being asked to do. So I'm trying to, okay, awesome, great. Let's play around with the idea. Let's figure it out and get just kind of the conceptual idea of how to do this. I remember I used SQL in the Java project, and I was using the SQL to put things in, retrieve things back. And so hopefully with Python it will be fairly similar, and it also gives us a good opportunity to reinforce some of those skills that we learned in the previous videos. So let me come and make myself a little bit smaller, and let's just I'm just going to do main.py. Okay, so now the question is going to be, okay, well, we actually need to get the database, right? So I can go to new terminal. All right, so I want to see SQLite version. Let's see if it's just, nope. All right, so do you know what time it is? It's Copilot time. That's right. I want to, and by the way, so what we're going to be doing is we're going to be asking Copilot, like, okay, well, how do we do this? And then what we're going to be doing is trying to investigate and find those nuggets of knowledge that, okay, great. Let's learn the concepts and understand how it's doing it. This way we don't have to do 20 hours of Googling. So there we go. I want to set up a SQLite project in Python where my Python script will be able to communicate with the SQLite database. All right, let's just see what it does there, and we'll figure out which libraries we need and all of that. Okay, so SQLite 3, awesome. So import SQLite 3, okay. So I'm not sure if I actually have that. I also know that I need to instantiate that database, right? Because it's not just that we connect to a random database. We have to actually have that database already, is what I remember doing in the Java project. Okay, so we can do this connect to the database. Now we need creates files if it doesn't exist. Does that mean that it does create the database? Okay, let's try it. I don't think this is going to work, but I'm assuming that we're going to have to create an actual database called my database here. Okay, so let's see. Connection is equal to SQLite 3, and then we're doing connect, okay? And now what are we trying, which database are we trying to connect to? My underscore database dot db, okay? So now we have something called cursor, and I'm not sure what this is going to be doing, but we'll have to investigate that. So connection dot cursor, okay, which is a keyword. Let's see if we have any. Let me move myself for a second. Factory. Okay, go to definition. All right, so we're probably going to class connection, which is what we did here, right? And then we have, what did it say? Overload? Overload, cursor, self, okay, factory, none equals none, cursor. Okay. What does the cursor line mean? It is just a single line in the class connection. Then it has an ellipsis. I don't know how to spell that, but it'll be fine. Dot, dot, dot. Explain it. Okay. There we go. So we'll find that out later. Let's, where am I? Okay, so it says connects to an SQLite database or creates it if it doesn't exist. So this indicates that it does do creation. But it doesn't give me where it's actually being located. That's kind of strange. Okay, but anyways, that's for another time. So we're gonna actually create the table. So cursor dot execute, and now we're going to, okay. Like this, and now we put in a string here. So, and I am going to be in the way, so I'll move myself. Create table if none, or if not exists, okay, users. All right, so here we go. Now we're actually creating the table. So we're gonna have one field of ID, another field of name, and another field of age. So we're gonna have 3 fields here. And this is in the users table, I believe. But we haven't even created the database. So are we creating the table or are we creating the database? Okay. I just want to actually try this just to see if it works. Okay, so ID is going to be an integer. It is going to be the primary key, and we are going to auto increment. So each time we put something into our database or into our table, it's going to create a new call or new row, and that row is going to just have a new primary key for that new entry, and it's going to be 1 higher than the last. So auto increment, okay. And now we are going to create a new column, which is name, and that is going to be text, and it is non-nullable. Okay, there we go. Awesome, awesome. And we're going to have age is going to be integer. Great, cool. So then I close out my parentheses. Yeah. Then I close out the string. Awesome. I don't know if it has to be this exact format. I think it should be okay, but if it doesn't work, that will be one of the candidates that I will be looking at. So cursor dot execute. Okay, so we're executing a command, and this is the command right here. Okay. So this is kind of what I want to investigate as well, because that goes into what I'm talking about with wanting to learn kind of the concepts of SQL within Python is, okay, so we have two parameters, Alice and 30, and we have these question marks here, but then we have name and age. So where is it actually putting it? Like, where does this Alice get shoved to? Is it here or is it here? Like, what exactly is going on? So let's write it out and then we'll investigate that in follow-up questions. Okay, so insert into users, which is the table that we just created, name, age, okay? And then we say values, question mark, comma, space, question mark. Okay. Okay. Then we end the string and we pass in a second parameter to the execute function, which is Alice, who is 30 years old. Okay. So we're going to be investigating this, but later. So now we have to commit something. So connection.commit. Interesting. I don't know why we need to actually, because doesn't this execute, perform the command there? So what are we doing a commit for? So query the data. Query the data. We do cursor dot execute, and now we do another SQL command. So the same thing. We use this cursor dot execute. Awesome. So select all from users. So we're going to find it. And then we're going to do rows is equal to cursor dot fetch all for row in rows print row. Awesome. So we're going to come in here and we get all of the rows. So this is going to return like a list of lists, right? And it doesn't really. Does it say the return type? List of any. Okay, so yeah, it's a list. And each item in that list is a like row, which will have multiple different like sections. You'll have how many sections? 3, ID, name, and age. So then we just print each row. Okay, so then we do connection.close. So we're closing the connection to the database. Connection.close. Okay, like that. Whew. I am curious if this is going to work. I'm doubtful, but we'll do Python, then we called it main.py. Python okay. Where is it located? So it created the database right there. Okay, in the current working directory. Awesome. So now we're going to come and we asked it that second question, right? Okay, so the question marks are used for SQL injection protection. Okay. Let's see. So I'm looking at a code snippet of type hints and method overloaders from the SQL connection class in Python. Let's break down what that cursor ... arrow dot 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 line means and why it uses the ellipsis. Okay, so this is the line that we are asking about, which is correct. It is a type of hint overload declaration, not actual implementation code. Okay. It's used by type checkers like MyPy. What is, okay, type checkers or IDs to understand how the method behaves depending on its arguments. Okay, well, that's great because I didn't understand anything in there. Let's try to reread that for a second. This is a type hint overload declaration. Oh my goodness. Okay, so the only thing that I understood in that is type. I understand type, right? You have int, float, whatever type it is. Okay. Hint, okay, what am I like telling the compiler, but Python is not compiled. So what's going on there? Overload, overload? Why? What am I changing, right? Like that implies that there's another function or method called cursor. Okay, and then declaration, we just declare the function. Okay, not an actual implementation code. It's used by type checkers and MyPy, PyWrite, or IDEs to understand how the method behaves depending on its arguments. Which arguments? These arguments? Okay. Overload. This means, or overload means this is one version of the method signature. Factory, none equals none means no custom cursor factory is provided. So this is part of that like design pattern factory. The factory pattern. Okay, so arrow cursor means it returns standard SQLite cursor object. Okay, so that's just like return type. Awesome. We've seen that notation before. Okay, the ellipsis means implementation is elsewhere. This line is just a declaration for type checking. Okay, because cursor method can behave differently depending on arguments. Here's the second one. Def cursor. So we have factory and then callable connection. And it returns a cursor object as well. Okay, if you pass a custom factory function, it will return whatever type that factory produces. Okay. And then again, the ellipsis means that we are not implementing it here. That's going to be somewhere else. It's almost like extern, right, in C. So you just say like extern and tells the compiler like, hey, I declared this variable. You're not going to find it within this like compilation unit. Go check somewhere else. And then, or actually it's like, trust me, it's in my project, just trust me. And then I believe the linker or something, once all of the, I forget exactly how it works, but all the compilation units get compiled, and then the variable that you called extern is going to be in like this unit, and then the linker links things together. I believe that's how it is. Don't quote me on it, but I think that's what's up. Anyways, def. All right. So somewhere else we're gonna find that. Awesome. Okay. And now what do we want to say? Now we want to go into this one. Okay. Go into this one and figure out how this is working. Can you explain this in detail? All right, we're gonna have it explain this in detail, and then I also want to figure out like why do we need to do this commit right there. I get this part, that makes sense. I get this part, that makes sense. So I also, something that's not exactly making sense here. I did this execute command, right? I would expect to be doing something like this. Whatever result equals like this. I would be expecting to do this command. It returns the results, and then I can go through them like this. Like instead of rows, I would just do result right there. But that's not what we do. We do that, and then we do something called fetch all. So this seems to be like two separate SQL commands, which we do. But I don't see this having any result. Okay. Okay. So cursor.execute, insert into users. Okay. And then name age. So execute, this calls the execute method of the cursor object. The cursor object is your interface to run SQL commands against the database. That makes sense. Insert into users. Here we go. So this is an SQL statement, yes. It tells SQLite to insert the new rows into the users table. That makes sense. Insert into users. I get that. The question that I'm having is, how do we, like, for example, in C, you do like print, and then you do or printf, and then you have your string, and then you can do like %f if you want to print a float, and then you can do %d if you want and %s string, right? Like all of these things if you want to print the ints, or if you want like a I don't know, unsigned integer, you can do is it u? I don't know. But anyways, you can do that. And where was I going? Yeah, so that %d is kind of just like a placeholder for like, hey, the integer which I am about to give you, put it here. Okay, well, I have a string here, so this is the one that I give you, but put it where? Put it here, or do I put it here? Okay, so it tells, okay, the double question marks placeholders are parameter markers. They prevent SQL injection and allow safe substitution of values. This is a tuple of values which are replaced, that will replace the question mark placeholders. Goes into the name column. Okay. So it prevents SQL. The row is added to the database in memory. You must call connection.commit to save to the disk. Okay. Well, I actually just need to ask a follow-up question. So I am passing in Alice and int 30, but I don't know where I am actually putting it into the string for the SQL statement. So this is the statement here. So, okay. This is indicating to me that I don't quite exactly understand how SQL statements are working. And the reason for that is because I thought that it was putting it here in the name, but actually it puts it here. Okay, so, um, I guess my confusion is I don't fully understand SQL statements. What do the name, age section mean? Then we have another parenthesis section for the actual values. Alice and 30. All right, so let's have it explain. Okay, so insert into users, name, age, values. Okay, this SQL command tells the database, insert a new row into the users table. Yes. And set the name column to Alice and the age to 30. So this part specifies which columns you're inserting data into. So I'm inserting into the name and age columns, okay? And then you can insert into all columns or just one column depending on your table. So this part provides the actual values that go into the columns. It's the second part, okay? The order must match the column list. First value, first column, second value. Okay, so it's just based off of the ordering. Okay, that kind of makes sense. I'm gonna come down here so I can chill a little bit more. Like, okay, so okay, so now let's go and try to figure out like, hey, what's up with those question marks, right? Like, how does that protect us? It said that it protects us against an SQL injection attack. Okay, how? Right? That's interesting. It sounds pretty important. I don't want to be SQL injected. So, and by the way, just for like context, SQL injections are when someone tries to go in and it says like, hey, what's your name? And in the name column you say, oh, my name is drop table, which is kind of drop table means like delete the table. And so then when you put that into an SQL command, which is right here, like cursor execute, you say cursor execute, and then you have here drop table, and then it says, oh, okay, bing, and like deletes your entire database or something like that, or table. So that's what the SQL injection attacks. It's like a way for a malicious actor to be able to put SQL commands into the text box, and then your program puts it in as a command, and then they're able to extract data from it or like cause harm or like havoc on your systems, etc. So awesome. Let's figure out how those question marks, and let me turn up my not volume, but brightness so I can see. Okay, let's figure out how to do it, right? So, why use question mark placeholders in Python? When you write this in Python, cursor.execute, insert into users, name, age, and then values. And now this is where we were going to be putting the values. We were putting Alice and 30 here, but now we're not. Now we're putting two question marks. We're just saying, hey, there's a parameter here and there's a parameter here. And then we're doing this here. Haha. Okay. You're telling Python, prepare this SQL statement and safely substitute Alice and 30 into the placeholders. Okay, so then this execute command or method will take care of safely handling whatever is the parameters in here. So we say this is a parameter. It's not any kind of SQL statement. So that's handled by this execute. We don't need to worry about that. Okay, this avoids manually building the string like that. Awesome. So now we kind of got here. So it said once we finish this execute, it was in memory, but it wasn't saved to the database. So we're trying to figure out like, okay, well then, what's the difference? Stored in memory, like RAM, the RAM of my computer, but not the actual database that we see right here. Is that what you're talking about? Okay, so why do we need to do the command? You mentioned something about in memory, but not, oh wow, look at the way I spelled memory. But not in the database. What do you mean, and how does it work? So I'm guessing that this thing that we're going to investigate right now is actually going to clear up two things, which is this one as well, like why we had to do this execute and then do this. I'm guessing that they're related. I just don't know how yet. Okay. I was about to say I want to get a cup of coffee, but then I looked at the time. It's almost 11, so I don't think coffee is a wise decision right now, but okay. Huh? No, not this one. Okay. So, is key to grasping how... Now my thing is at a weird angle. There we go. Now I can clearly see it straight on. What is connection.commit? So in SQLite and most databases, changes are insert, update, delete. So your CRUD operations, okay? So are made inside a transaction. Okay, these changes are not saved permanently until you explicitly commit them. Okay. So this tells SQLite, I'm done making changes, please save them properly. Okay, so that makes sense. It's just a way that like cursor. Hold up a second. These are two variables. This one is a connection, right? Hold up. This one is a connection. And cursor is a method within this connection. Okay. Okay. That might need some investigation as well to figure out, well, who's who in this world, right? Who is who? So, let's keep going. What happens without the commit? Well, obviously, this is not going to update the database, right? If you run this here, but don't do the commit, the changes made in memory. So SQLite holds it temporarily. If your script crashes or you close a connection, the change is lost. Does that... that doesn't seem to be following the ACID principles, though. So before we okay, I'm gonna ask. Doesn't this break ACID principles? Okay. So let's just first see like why use the transactions. So transactions allow you to make multiple changes safely. Roll back if something goes wrong. See, rolling back also, you're not, right? You're not supposed to, if a transaction succeeds, it's not supposed to be able to be rolled back, right? Avoid partial updates. Okay, so this is a legit one here. Avoid partial updates, inserting into the table, but failing in another. Okay. Bonus, what is connection.rollback? If something goes wrong and you want, okay, maybe what this is if you have to do multiple transactions and you want to say do all of these transactions or don't do any of them. And then if one of them fails, you can do that rollback and you don't do any transaction, which would be in conformance with ACID principles. I think that's what's going on. Okay. I'm just gonna ask this question anyways. I just want to confirm it. Okay. So we got that, and it didn't quite clear up as much as I was hoping with this, because I still would expect it to return back something. And then I'm gonna say I would expect to do something like this. No, hold on. Result, and then comment this one out. Yeah. Okay. But obviously this is not the way to do it. Why does my way not work? And why does your way work? Okay. So now we have to come here and look at the woo. All right, it's gonna party for a little bit, and I think we're done. Okay. So, great question, and no, it doesn't break ACID principles. In fact, the use of connection commit is part of how SQLite enforces ACID compliance. Let's walk through what ACID means and how to apply it. So, what are the components of ACID? It needs to be atomic. Idity. Whatever. Whatever. It needs to be atomic. Okay, here we go. All operations in a transaction succeed or none do. Okay, so that's kind of how we can do that rollback, right? Consistency, the database remains in a valid state before and after the transaction. Okay, isolation, concurrent transactions don't interfere with each other. So, like, I think it means actions at the same time. Durability, once committed, changes persist. Okay, there we go. Even if the system crashes. Okay, there we go. Once committed. So there we go. That's kind of what I was getting at, because I remembered something about this durability one where it was like, wait, you can't just go back if the database crashes or if you lose connection. It needs to persist. No, once committed. Okay, here we go. So we do this. The changes are not durable, right? That's correct. That's what I was confused about, or suspicious about, I should say, until you do the commit. If something goes wrong before that, you can roll back. This ensures atomicness. Once you call commit, SQL writes to disk, ensuring durability. So rather than breaking ACID, this behavior enforces it. All right. Woohoo. Okay, so we can do two things here. So we can insert Alice and Bob and then commit it. We say, hey, I want to either insert both Alice and Bob, or I want to insert neither one. It's an all or nothing kind of deal. All right. Okay, so you're actually very close. Your instincts are solid. Okay, that's just like hyping me or something. Just tell me. Okay, so here. This does work, but only under certain conditions. The cursor.execute method returns the cursor itself. So, yeah, we need to figure out what this cursor is. What is cursor? The only cursor that I know is that that AI that's trying to take my job. That's the only cursor I know. So I have a very negative opinion of Mr. Cursor. Hopefully this one's a little bit nicer. Okay. So this method returns the cursor itself, not a list of rows. Okay. So when you iterate over result, yeah, you're really iterating over the cursor object, which lazily fetches rows one at a time. It's valid, but with caveats. If you reuse the cursor later, it might be exhausted. If you need to store or manipulate the rows, you'll want them in a list. So this is the most common one. This preferred because fetch all grabs all the rows at once and stores them in a list. You can reuse rows, slice it. Okay. If this is the case, why do I need to do the select all from users command at all? Why don't I just do a fetch all command? Okay. All right. Why must you run the select all from users before fetch all? Fetch all is not a query; it's a retrieval method. What's the difference? That's going to be a good question. We need to figure that out. It doesn't know what to fetch until you tell it with an SQL command. Okay. So what happens, here's what's happening. So we do this execute, sends the SQL query to the database. The database runs the query and prepares the result set. Where does it store it? Fetch all pulls those results into a list. Wait, from the air? does it pull it from the ether? Where's it pulling it from? It's not pulling. We didn't pass in a parameter here. We didn't do like equals result and then put result in there. Like, the only other thing that I can think of is because cursor here and cursor here, there's like a member variable in here maybe. Wait, where's the class? Connection. This is connection. This is not cursor. Anyways, what I was thinking is that they're probably inside of cursor. Maybe I can just go here, find definition, or go to definition. Awesome, thank you. Thank you for that. Here, please don't be. Wait, this is the exact same thing. This is just where I came from. That's where. How about the second one? Ah, it's where I came from. Okay, this is much less. I was thinking that there was like a private member variable within the class, and it's gonna pull it from there. But anyways, if I just do this, you'll get an error. Cannot fetch, no query executed. Okay. This doesn't quite make sense because where am I actually putting the results when I do the execute command? Fetch all must know the memory location at which the results are stored. Okay. Okay. So I'm sending in SQL query to the SQLite engine. Here's what happens internally. SQL processes the query, prepares a result set. The result set is stored inside the cursor object, not in a separate variable or memory location you manage directly. So I think it is just like a member variable. The cursor now holds a reference to this result set. It's ready to be read. So you're not putting the results anywhere manually. Cursor itself becomes the container. Okay, fine. Take all the rows. Yeah. Okay, we get that. That's fine. What's it gonna do? We need to investigate this. So can you tell So what are we doing? What are we doing here? So we have a connection to a database. So some kind of, so SQLite, this is the library, and we call this method connect, and this will pass back to us a connection and object or class, right? And then I do a constructor to this cursor, which is here. Here's connection class, yes. And then I have this cursor, which is declared somewhere else, and who knows where, because it's not here, right? It's an external variable. So then we get back something else. I don't know what type this is. Well, actually, wait, we do know what type it is. It's cursor T, or cursor. It's a cursor type. That's super helpful, obviously. Go to definition. Class cursor. Hold up a second. Hold up a second. Let me move myself here. All right, hold on. Okay, here we have the fetch all. And we have more over here. That's it? There's no implementations here. Okay. Wonderful. Okay. So this does two things. Connects to the SQLite database. That makes sense. If the file doesn't exist, fine, whatever. Returns a connection object. That's kind of what I'm curious about, which represents your link to the database. This connection allows you to create tables, insert, think of connection as my gateway to the database. Cool. So now cursor. Well, what is this cursor? This line creates a cursor object, which is your tool for executing SQL commands. Well, I thought this one was. I can do insert, update, delete, query. You use it, cursor.execute, okay. Retrieve results here. My library card, it gives me access. This is the assistant. Okay, so it's just an assistant that provides functionality. Okay. And yeah, we do connection.close. That's giving my library card back. Say, hey, I'm done. Okay. So I think more or less I get it. Okay. Cool. Yeah, this video was more of just like a playful video of, just trying to learn things, trying to make sure that playing with the ideas, just learning the concepts. So I think I'm going to leave the video off here. I had a fun time. I hope you guys had a fun time as well. I feel like I learned a fair amount. And yeah, it was more of a low-key, just enjoying ourselves kind of video. And if you are interested, subscribe. I would love to have you along for this journey. If not, that's fine too. And yeah, so goodbye and have a good rest of the day. My name is Timothy Lee Grant, and bye.